Recently, I did a conversational deep dive on my YouTube, just going over all the components that make up a typical request that's going to come from a local AI agent out to a inference provider like Anthropic or OpenAI, and then back down through the harness and how that interacts with the environment. And I'll summarize. I wanted to summarize briefly kind of where we landed on that. It's about a 40-minute long video, and I think I can probably summarize it in 5 minutes or so, and then walk over some examples of why for certain use cases, a harness custom designed for the job can be a tremendous value add. I think the underpinning of all this, though, is the reality that whenever we design systems, we generally have to design for kind of that, I like to say, that minimum viable user, that person that doesn't think like an engineer, that person that's not going to come in and use your app the way you want them to use it. They're going to use it in some absurd way. That's a reality of developing software tools, and I think that is just as relevant for AI as it is for anything else. So let's recap briefly what we talked about in that video. Save you the 40 minutes unless you want to go back and watch it. If you want the deep dive, that's there. As is the case with most of the stuff I put out, totally candid, no script here. We're just going to have a conversation, and I try not to meander more than I have. So as I think about this, I kind of think of there being, three layers. Maybe we'll even collapse it into two. So one layer is going to be the provider, right? So at the provider layer, and we'll put that up here, provider. This is going to be your Anthropic, OpenAI, or local AI, something like maybe Llama or whatever that's running on your machine or a server, if you happen to have one of those. So that's kind of the provider. Now, outside of the local AI scenario where you have a ton of control, obviously, that's the whole idea. When we talk about providers like Anthropic and OpenAI specifically and primarily, but also Gemini and xAI, and also like Alibaba and the Chinese hosting providers, in most of these cases, there's quite a bit going on when your request comes in. So like you send a request for inference, a request for, AI to do work for you into the provider using an API call. And this is handled by your harness. So if you're doing something like using Claude Code, when you enter a prompt and hit enter, that is making an API call out to the endpoint in Anthropic to provide that session. And something not everybody really understands about AI that I think is important to kind of keep in the back of your mind if you're going to be building systems with AI is that every single individual call that goes into an LLM is a atomic entity. So the concept of a session, like you sit there and have a conversation, user message, AI message back and forth, this is just a bunch of atomic requests being chained together. As we talked about in my other video at length, each time you send a request into the model, all of your previous requests and responses from that conversation, unless it's been compacted, are sent along with it, because the AI, every single time it gets a message, has to sort of become alive, so to speak, read the whole conversation history at once to get the context of what's going on, read all the tool calls, all the loaded files, and then be like, okay, I'm up to speed. Now what did you say? And then it reads whatever the current user message is, or whatever the current file being dropped in, or whatever the piece is for it to work on. So when a request goes into the provider, there's a lot of stuff that happens in the background, and I've done that little bit more deep dive video, and I could probably go twice as long easily talking about caching and a lot of other stuff that's happening up there. It's pretty important when it comes down to cost, but the main thing I want to get across is that the provider is almost certainly appending more text to your prompt. So when you send it into the provider has sort of like a grand system prompt, sort of like a steering guidelines body of text that goes to the model along with your prompt to try to steer the model's output. This is done for a lot of reasons. So one of which is just the provider wants the model to act a certain way, and it wants to suppress artifacts that might have come out of that particular model build. So GPT-5.5, I mentioned this in my last one, had like a whole big thing for goblins, where if you ran it raw, it would just refer to everything as a mythical creature or a goblin. And this was just like a weird anomaly that came out of building that model. So OpenAI talked, quite a bit about how they were bolting text onto all the prompts that were going to the model to suppress that behavior. A really good example in the public eye was whenever xAI with Grok went and fiddled with their system prompt around the middle of 2025, I think it was. And the result was that they woke up the next day to Grok absolutely going unhinged on Twitter with these extreme racist, violent remarks and comments because they had basically given it a system prompt that significantly reduced its level of political correctness and caused it to be very unhinged in its behavior. And that's a whole story that's maybe worth going and reading about. I digress. So there is a lot of text being let's say, appended to your message at the provider level. Wow. And now let's talk about what's happening on your machine as you go to send out with something like, Claude Code or a harness running on your machine, right? So this next box I'm drawing here is going to be the harness. This is going to be your ChatGPT app or Claude, etc. And the harness is responsible for building that API call and managing the API response from the model inference provider. But it does a lot more than that. So we covered this in my other video, but I'll touch on some key components. The main things that are happening here is it's running an orchestration loop. So it's orchestrating itself, and it is, ultimately taking whatever an input is, processing this with AI to deliver an output. But the way it does this is it's in almost all cases, we are going to have, let me grab another text box here. We are going to have some stuff. First, we're going to have a system prompt. This is either written by the harness builder, or in some harnesses it's exposed to you so you can edit it. And in some harnesses it's basically non-existent and you get to go build it from scratch. So if you take something like the Pi coding agent or the Pi SDK to build an agent on top of, it basically has a system prompt that's like, you are a helpful assistant. That's it. So it's a placeholder essentially for you to go tune it. But you're going to have a system prompt, which is essentially designed to sort of set the stage for the AI around what to expect from the user. Interestingly enough, the system prompts in most of the apps you'd go download, like Claude Code or ChatGPT app or apps like this, are heavily system prompted towards agentic coding. So if you're not building apps on your system, there's probably a lot of nonsense in that system prompt that doesn't apply to you. And that's going ahead of your prompt. Additionally, if there are tools and skills, so tools and skills and plugin metadata. So like tool descriptions, MCP tool descriptions, built-in tool descriptions. So most all the harnesses have like read, write, grep, bash, basic tools, and then you might have MCP tools connected as well. That's gonna get loaded. It's gonna get all this context, so it sort of knows this, and it's gonna glean a lot about what sort of environment it's operating in based on the tools and skill definitions and plugins that are connected. The more heterogeneous this is, then the less focused the overall experience is going to be, because the agent's getting all these things pulling for its attention, which attention is a very important detail when working with AI, because it needs to pay attention to the correct tokens across the overall submission that's coming in with each turn. So all of this is going in, and then there's a lot going on here, and then eventually you do get to the user message or the user prompt, which is going to be what you actually typed in. But in many cases, the user message or user prompt is also modified to have it sort of fit the harness and model. So there's a lot going on here. Once you've sent the user message, another thing that I think is really critical to call out, especially for what we're about to talk about, is that a lot might happen after that. So if I send a user message, it includes the system prompt, it includes all the tool definitions, all the skill descriptions, all the plugin metadata. It goes to the provider where it gets prepended with the provider prompt and the provider guardrails, and then likely screened by an additional version of the model or a different model that's job is to enforce safety and prevent hacking and bioweapon development and stuff like that. at the provider sets, there's so much going on, like 10,000 tokens going in, and like 300 of them are what you wrote, maybe. So I say all that to say that putting all of the weight of getting good work done with an AI agent on the user message is bad system design. So whenever we use something like Claude Code, the harness is built to be a general purpose tool. It's built to be something like, it's built to be an adjustable wrench, right? You can use it for a lot of stuff, but it's not the end all be all of a specific job. It's a universal fit tool. And so as a result, it's great for whenever I want to develop a slide deck, work on a, flyer for my daughter's softball game, and then go over here and, like vibe code an app. If I want to do all that stuff from one tool, I need a general purpose tool. But what if we want to build an agent for a specific real job, like a SOC analyst or, an AI ops engineer, right? Like when we want to build an agent for a specific job, it becomes obvious to us as we understand the system that there are a lot of opportunities for us to optimize the work and optimize the harness around the work. So that's what I want to talk about a little bit here today. And I want to talk about it through the context of building a harness for a security operations center and to investigate security alerts. But I think that this transcends that completely. And almost any work you want to do with an AI agent, these concepts are very applicable. And I hope it helps you understand how important harness engineering can be. Because if you build the right system prompt and you have only relevant tools and plugins and metadata connected, and you then also have, talking about the tools, skills, and plugins, after the prompt lands, the agent then gets to read these tool descriptions and plugins and skill metadata, and it then is able to go load skills on demand that directly speak to the work that's at hand. So it's got skills for, proprietary data access within the organization and how the workspace should be organized and how things should be reported on. And all of these different skills are available. Then if the user asks for a threat hunt to be done about something, the user does not provide, I think it's more important to say, not the user doesn't need to describe how to do the work. It's more important to say there is no value added whatsoever by the user describing the work, because the way the work should be done is built into the system. It's built into the harness. The user's job is just to convey intent as simply as possible and let the system work the way it was engineered to work. Ultimately, when built correctly, a user prompt of 7 to 10 words should be equally, if not more effective than a thesis. And so I want to show an example of something of that nature. So we're going to pivot over here and we're going to look briefly at a investigation in progress that I kicked off a few moments ago around a threat hunt that's been going. And I want to talk a little bit about this design, what's happening here, and how this deviates heavily from a general purpose harness. So this is a harness that I built to investigate security or network performance issues using the metadata available in ExtraHop, which happens to be where I work. And so let me high level this one now that you are armed with all of that context from the other conversation. So when you come in here and I say something like, perform a threat hunt in my environment for the Handala attack group, focusing on just the past 7 days, I am providing a clear description of the type of work I need done, right? If I am a manager and I walk up to an experienced, 5-year, tenured senior analyst on my security team, I shouldn't need to say more than that because I know this person knows how we do threat hunting here. They know the tools we own. They know where our data lives. They know all of this stuff. So I can go convey my intent and the needed work, and I can then trust this person to do what they've been trained to do it right. So that is what a custom harness does. So in this case, this harness is armed with many, many different skills that describe how we do work here. So it's going to go through things and have skills that talk about how to specifically interface with the ExtraHop system, how specifically we want triage to be performed, how specifically we want you to do security research here, what sources are available to you. How do we want you to report on these investigations? Like once you've gone through and done your job, what does a good report look like to me? All of this is defined as documentation. So think about how a human would do work, right? If I woke up and didn't have my coffee and I forgot how my boss likes me to report, in a well organized security operations center, hopefully there's documentation I can go read. It's no different with your agent. So that is the value that you can build into a harness. And I'm not saying that skills are the only way to provide documentation to an agent. In fact, I'm pretty convinced that skills are a transient thing that we will eventually move beyond as we come up with better ways to approach this. And I think they may be more traditional ways to expose this, but that's not the point. The point is that intelligence can grow to infinity, but knowledge is still required to leverage intelligence. And so the harness allows us to provide highly ergonomic access to knowledge and tools for high intelligence to do good work. And that's really what I want to converge on. So by providing scaffolding in the form of knowledge that is structured to allow the agent or the AI to think through the problem creatively, but understand the criteria that's expected of it. We are not saying step 1, step 2, step 3 in general. We are saying, here's what good looks like, here's what's acceptable, here's what we want. Think about how, I don't know how you work individually and how you prefer to be managed. For me, I'm a very creative person and I'm a very self-paced, self-led person. I never went to college. I was homeschooled. I finished high school when I was about 15, started doing ranch work. I've done all sorts of different things in my life. I've, built my way into my career and gotten to where I am through being a almost self-destructively curious person. And this persona is my power, right? If I deviate from this persona, I am neglecting what makes me powerful at my job. What makes me powerful is this absurd desire to fall asleep learning something and wake up learning something and learn something all the day in between. And if I try to harness that correctly, then I can use it to become like a successful human being, which I think I've mostly managed to more or less do. And that is, but if I were to revert from that and try to fall into this follow clear instructions, don't think way of approaching work, I would be very mediocre at best. So I think it's very similar with AI. You have a very intelligent thing that is trained on more knowledge than will ever fit in your human brain. And so if I can leverage that intelligence and knowledge with guidelines and not hard rules, I can get the best work out of it. That's my opinion. So that's how I try to build skills. I also have a lot of things that are suggestive. So here we have where we require an investigation plan to be built. So this agent is doing work. It's required to build a plan for its work. So it wants to go do this threat hunt for the past 7 days. It has to it's being told first before you start, write a plan. Tell me how you're going to hunt. Tell me the coverage and search strategy. Build out the steps you intend to do and track those. So each step it's taking that's set up, it is providing a description of its outcome, linking to the files that it used as it steps through here. And further down, it has plan evolution and decision history, where as it runs into things that change the way its perspective is, because no plan survives contact with the enemy, we expect this to happen, but we want it to log and track its planning and thinking process. So by making it do this, we are forcing so much structure onto the agent without creating rigidity that doesn't allow it to do good work. As it goes through here and uses tools and performs work, all of that gets tracked, right? It's going to do search with the internet. It's going to use ExtraHop tools to search for data in ExtraHop and sort of perform its work. But what I wanted to call out is that we've tried the way we've structured this harness to make it good at this job is we've made it easy to work with its data source. We've provided readily available, decent quality documentation that steers but does not overly constrain. We've built in suggestions of what good looks like by providing it with the need to fill out a plan. the requirement to produce a report, and the requirement to log its decision-making process. This means that because it's working on this type of task, shortcuts become obvious to the reasoning loop. So whenever an AI is doing work, it reasons over the work, which means it reprompts itself in the background to sort of look at the way it's doing work and judge itself. And whenever we build this kind of structure in, that reasoning loop becomes very opinionated, because it then sees where the agent is taking shortcuts, and it sees what's being suggested and steers itself back. And so we don't have to go in and put a bunch of anti-patterns like never do this and don't hallucinate that and don't do this. When we build structure that makes the easy path, the happy trail, be the one it wants to walk down, is the right one. And that is why harness engineering, I think, is so critical when we talk about these non-agentic coding use cases. Because if agentic coding is the use case, everybody's building for that. Like Claude Code is freaking great at that. Like you don't need to go develop an agentic coding harness unless you're one of those guys that's super opinionated about how your work should work. And then in that case, you're probably already using Pi or OpenCode or something, and you're doing it your way. You have your own skill structure, and you're probably not watching this video because you realized I was speaking to the choir. But for other use cases, I think this is such a critical thing to be able to add on. Now, let's look at some completed work, and I want to show some examples of kind of what we're getting out of this, right? So I'm going to go back and find a completed investigation. And, so in this case, we were able to finish an investigation, complete our plan. So we go view the plan here. We can see what its hypothesis was, all the steps it took, all of these guardrails and guidelines we built in. And then it built a report, right? And the report that it wrote here was built from a template, because this is part of the investigation reporting skill, includes an HTML template it's expected to fill out. And the template includes all of the major categories here. It includes the timelines, it includes the entities, it includes the scope, it includes the Q&A format for describing the major reasoning it did. It includes a section for third-party enrichment. It includes these sort of challenging areas around alternatives that are being considered. It requires an evidence manifest, right? So on and so forth. All of this is structured to allow us to get this great outcome, while we're being very careful to not simply use an AI like a SOAR or a playbook and create so much determinism we can't get intelligent work. I hope this was interesting. 22 minutes, I think that was pretty good. I probably meandered a little. I like to talk. Sue me. I hope, though, that this was good. Reach out if you have questions, you want to talk. I'd love to talk about this stuff. I think it's super interesting. I think there's a lot of people talking about the vibe coding and agentic engineering side. And I think there's a lot of marketing and salesmanship going on in the agentic SOC and agentic NOC, and how to use IT, how to build more robust IT and security systems using AI augmentation. And all of that's great. And there's a lot of killer ideas, but like nuts and bolts is cool, right? Like this is fun to talk about. So let's have these chats. If this is interesting to you, if you enjoyed this video, let me know. If this format's okay, let me know. And yeah, hope you have a great day and go do something productive.